Good afternoon to everybody, dear student. So, today new topic we will start, and that topic will be radical and their valency. So, yesterday we have discussed about the variable valencies. Why do some element have variable valency and how we will give their name, okay, like OUS and IC when it is used as a suffix for these for elements. So, today I have told you yesterday that we will start with radicals. So, we start now with radicals. So, what are radicals? So, radicals are what? Atom or group of atom, okay, atom or group of atom of different element, sometime different element having positive or negative charge act as a single unit. So, this is the definition of radicals. In radicals what happen? It may be of single element, okay, it may be single element or may be a group of element, okay, which will form a single unit. They will form a single unit and act as a single unit, and they have either positive charge on them or negative charge on them, okay. So, this radical term is similar to that of the compound, okay, but it is different in the sense, in compound the element of different element they combine together with each other, okay, they combine with each other to form a compound, but that compound do not have any charge, okay. But in case of radical, if they are forming the group by combining two different elements, then they will have either positive charge or negative charge on them, but during a chemical reaction they will behave as a single unit. So, whatever the charge they are carrying with them, they will have as a single unit, that means that belongs to the both, okay. For example, like radical, you can take one radical NH4 plus. This is a radical where it is formed by nitrogen and hydrogen, okay. It is formed by two elements, that is nitrogen and hydrogen, but it is carrying a positive charge there, okay. It is carrying positive charge at the top, at the power I have written positive charge. So, it is combined by having nitrogen and hydrogen, yes, but there is a positive charge on it. So, it is a radical formed by combining two different elements, that is nitrogen and hydrogen, okay. But in case of compound CO2, this is a compound, there also we have combined it together by taking two different elements, that is carbon and oxygen, but in this case they are not having any charge on them, they are neutral, okay. So, it is neutral. So, what it is? A compound. So, compound is neutral. So, it is also formed by two element, okay, but they have no charge on them, okay, they do not have any charge, because if you know carbon dioxide is formed by carbon and oxygen. So, in carbon only one atom is there, and oxygen how many atom is there? Two oxygen atom is there. Now, what is the valency of one carbon? It is 4. Yesterday we have studied about the valency, that is valency of carbon is 4, and that of oxygen, one oxygen is 2, and how many atom of oxygen are there? 2, that is altogether 4. So what happen while combining, though it is a covalent compound, we will study about their sharing, it will do or transfer of electron, electrovalent bond, about that also we will discuss here. So here what happened, 4 plus 4 minus 4, it will behave like that, and they will cancel each other out, and they will not have any charge on them. So it act as a neutral. But in case of ammonium ion, this ammonium ion, what will happen is that nitrogen having valency 3, it will behave like a positive, and hydrogen will have charge plus 1. So what will happen, it will behave like that, and it will have charge plus 1. So minus 3 and plus 4 of hydrogen. Hydrogen will lose and nitrogen will gain the electron, like yesterday we have studied. So all together as a whole, what will happen, it will have a positive charge on it. Nitrogen will gain electron because its electronic configuration is 2 5, and it will require 3 electron to become stable. So its valency is 3 but in negative, whereas hydrogen electronic configuration is 1 and it will lose the electron and it behave like a positive, and here 4 electron hydrogen is there. So 4 plus 4 and minus 3. So it altogether behave like a plus 1 positive radical. That means it will carry a positive radical. So there is a difference between NH4 and CO2. CO2 is a compound, it is a radical. Why it is called a radical? Because it carries the charge on it. Okay. So now radical are also divided or classified on the basis of number of atom or the element involved as a 2 types, that is simple radical and compound radical. Okay, there are 2 types, they are simple radical as well as compound radical. So example, it is here, simple means if a single element will act as a radical, then it will be called as the simple radical. For example, let's take aluminum. Aluminum atomic number is 13. Yes, aluminum atomic number is 13 and its electronic configuration is 283, and in its outermost shell it has 3 electron and it has a tendency to lose electron, isn't it, to get the stable electron configuration of 28. So when it will lose electron, it will carry the positive charge because it will lose the electron, 3 electron, and will have 3 extra proton in it, and hence it will carry the charge. So if proton is here at the neutral case, plus 13 is there, and electron, it will be minus 13 because the atomic number is 13, that means proton and electron are equal. And when it will lose, if it will lose, it will lose, okay, it will lose, then what will happen, the proton will be plus 13 itself but electron will be minus 10. So altogether plus 3 charge will be there. So aluminum will carry plus plus plus. So in this case aluminum acquired the positive charge on it, and it is a simple radical because it is a single unit. So previously I have explained about the ammonium. So in that ammonium, 2 element, that is nitrogen and hydrogen, were combined and it was carrying a negative charge on it. So that is what a compound radical, the radical which are formed by combining 2 or more element, okay, and carrying the charge on it. Like another example is hydroxide, sulfate also there, okay, these are also examples. So another type is compound radical. So this is the classification of the radical on the basis of number of atoms or the element involved in it, okay. And another method or another basis on which the radicals are classified, they are electropositive radical or electronegative radical. So what is electropositive radical? By the name itself it is saying electropositive, electrically positive charged particle group of radical are known as electropositive radicals. Okay, so which have carries positive charge on it. Okay, and the one which will have negative charge on them, okay, those radical which have negative charge on them, they will be called as the electronegative radical or acidic radical, or other sense we can say non-metallic radicals. Okay, so what happen? Electropositive means having positive charge. So like here aluminum having a positive charge, how it has done? By losing electrons. So electropositive radical are formed when any atom of an element or a group of element combined together, or a radical, if they will lose electron, they will acquire positive charge on them. Okay, by losing the electron they will get positive charge on them. That's why they are called electropositive radical. Okay, and the one like chlorine, so like chlorine electronic configuration is 287 and it requires one more electrons. So at the beginning proton is plus 17 and electron is minus 17. As a whole it is a neutral, but if you take, then what will happen? Proton will be plus 17, whereas electron will reduce, electron will increase and it will become 18, and as a whole it will be minus 1, and chloride, this chlorine ion will carry Cl minus. Okay, so this is a electronegative radical. This is formed when it will lose electron, this is formed when it will gain electron. So this is what? This is electropositive radical, and this is what? This is a electronegative radical. So this is about the radical and the definition which we have seen. So let's same thing, let's see in the slide. Okay, so slide please. So radicals are what? Okay, so definition you can write by looking at the screen. So a radical is an atom or a group of atom, okay, atom or group of atom of different element having positive, their emphasis positive and negative charge. They will have either positive charge on them or negative charge and act as a single unit. They will act as a single unit. Okay, so during chemical reaction there will not be differences between the element which are involved, they will behave like a single unit. So on the basis of number of atoms, radicals are classified as simple radical, so or simple radicals, and radicals which are formed from a single atom, example chlorine ion, that is Cl minus, which is also called chloride, aluminum ion, that Al3 plus, and hydrogen ion, that is H plus. So these are the example of simple radical, because single element is involved in possessing the positive charge either by gaining or by losing the electron. Okay, now next is a type is compound radical. So what are compound radicals? Radicals which are formed from two or more than two atoms are called compound radicals. For example, OH minus hydroxide ion, okay, and SO4 2 minus, that is sulfate ion. So on the basis of number of radical it is that, and on the basis of their electric properties or charge on it, they are classified as electropositive radical and electronegative radical. So what is the definition of electropositive radical? The radicals which have the capacity of losing electron. So losing electron, so when they will lose electron, what they will have? They will carry positive charge, and a positive charge on them are called electropositive radical, or other way what they can be called as basic radicals or metallic radicals. So generally these are metallic in nature, means they have a tendency to lose the electron and they are metallic in character. Okay, that's why they are also called metallic radicals. Okay, and another type of radical is electronegative radicals. So what are electronegative radicals? The radicals which have the capacity of gaining electrons, capacity to gain electron and carry negative charge. So negative charge on them are called electronegative or acidic radical or non-metallic radical, or they have non-metallic character on them. That is like example oxide ion O2 minus and NO3 minus means nitride ions. Okay, okay. So with this we have classified the radical into the different types on the basis of number of atoms and electric charge on them. Okay. So next slide please. So now some example of radical and how they have acquired the positive charge or negative charge on them, it is explained here. So look at there, the definition already I have explained you again, I explained. So example, if you see, for example, for a single element radical, that is simple radical like aluminum and chlorine, look there, aluminum. So in aluminum as a neutral atom, number of proton in the nucleus is plus 13 and number of electron in cell is minus 13. Okay. So if it try to attain electronic configuration of noble gas, so what it will do, it will lose its 3 electron. So after losing its 3 electron, now what will happen, number of proton in the nucleus will be plus 13 between it, because it will not undergo chemical reaction, whereas number of electron which are found in the outermost cell, okay, not the innermost cell, outermost cell electron or valence electron only will be transferred. In that case it will have minus 10 electron after losing 3 electron. So net charge or valency, what we can say, it is plus 3. So aluminum radical will have Al at the top, the power plus plus plus, that is 3 plus it will have, and it will act as a positive radical. Okay, it will act as a positive radical. Now look at the chlorine. In chlorine, number of proton in the nucleus is 17 plus 17 having positive charge, and number of electron in the cell, that is minus 17. So if it wants to gain electronic configuration of noble gas, so it has 1 electron less in the outermost cell, so it will acquire 1 electron, and what will be, number of proton in the nucleus will be plus 17, whereas the number of electron will increase to minus 18. As a whole, if you solve it, you will get net charge or valency of minus 1, and chlorine radical it will be shown as Cl minus. Is it clear? So that is for the simple radical. Now another example of the compound radical is given there. So for example, ammonium, okay, ammonium NH4 plus. So here what we can write for understanding itself, for understanding only, so valency of nitrogen plus valency of 4 hydrogen atoms. Okay. So it is formed by nitrogen and hydrogen, and nitrogen is only one atom and hydrogen is NH4. It should be lower fixed, that NH4 it should be 4 should be down, but you have to understand it. Valency of nitrogen and valency of 4 hydrogen atom should be there. So valency of nitrogen is minus 3 because it requires 3 electron to be stable, whereas one hydrogen atom can give 1 electron, so it carries positive charge. So there are 4 atoms, so altogether minus 3 plus 4 equal to plus 1. So net valency equal to plus 1. So ammonium radical will carry positive charge on it. Okay. So another example in another side, if you look, hydroxide or the negative radical example is given, that is OH minus, that is valency of oxygen plus valency of hydrogen. So valency of oxygen is minus 2 and the valency of hydrogen is plus 1. So, as a whole it will have minus 1. So, the net radical valency of hydroxide ion will be OH minus. Is it clear? So, with this example I want to give only a understanding how the element will carry radical or charge on them, whether it may be single element or a compound radical. Okay. So, this is about that. Now, next slide please. Now, next topic that we are going to study about the ions. Okay. Next thing is about the ions. So, what are ions? Okay, let us see what are ions. So, just now we have studied about the radical. In radical also there was a charged. Okay. So, here also similar type definition there. The positively or negatively charged atom or atoms or radicals are called ions. So, any charged atom or radical, if they will carry either positive charge on them or negative charge on them, they will be termed as ions. Okay. And an ion is formed by losing or gaining electron. How ions will be formed? Ions will be formed only when they will gain or lose the electrons. Okay. If they will share the electron, then there will not be any charge on them, they are sharing. Okay. There is no transfer of electron between the atoms or the elements. So, only when there is a transfer of electron between the atoms, then only they will have ions or the charge on them. Okay. So, like radicals, they are also of two types, that is cations. Cations means having positive charge on them. Okay. And they are formed by losing the electron, example Na plus, Ca2 plus. Okay. Like that. Other example are also there. And about anion means any particles or atoms or radicals, they will carry negative charge on them, they are called as the anion. And how they are formed? They are formed by gaining the electron, like chlorine ion, so which we have already explained. So, this is about the ions and what are their types. Okay. So, what are ions and what are their types? A cation and anion are two types. Cation means positive, anion means negative. Okay. So, now sometime we can see how to name the ions or the radicals. Okay. So, first how to name name an ion. Look at there. So, while naming a single element ion like cation, in case of cation means metal. So, in case of metal, there will be valence electron will be 1, 2 and 3. So, those element which have valency electron 1, 2 and 3, they will be termed as metal. And if they are single element like aluminum, okay, magnesium, boron, etc. So, if you see there how it is named, if so single valency, okay, single element, there are some element yesterday we have discussed about the variable valency as well as monovalency. Yes. So, sodium Na plus, we call it simple element plus ion. Na is the symbol of sodium having charge positive. So, we will call it as a sodium ion. Similarly, magnesium charged, how many charge it is carrying? 2 plus, that is magnesium ion, that is Mg2 plus. Simply we will call it as a magnesium ion. So, similarly, boron ion we will say. And about the element or the radical or the ions which will carry some element, they like in case of in case of variable valency. Okay, if they will show the variable valency, in that case, so how we will name them we have already discussed, like the element which will have low valency, they will be suffixed by OUS, and sometime in Roman number we will write 1, 2 or 3 according to the valency they possess. Okay, and lower valency 1 or 2 or 3 according to that, and sometimes we will write mercurous oxide like compound while forming. You have to understand iron 2 oxide, iron 3 oxide, ferrous 3 oxide, ferrous it will simply say, or sometime iron 2 oxide it may say. So you have to understand. So sometime mercury, for example there it is given mercury 1 iron, simply we call it as a mercury 1 iron or mercurous. Okay, we have studied earlier. So similarly if it is showing 2 valency, that we will call mercury 2 iron. So while naming we will call mercury 1 iron, which is indicating Hg plus iron, whereas mercury 2 iron we will indicate it as a Hg plus iron. Okay, so mercury in simple language. Okay, so that is about the ions. So if anion is there, okay, this is about the cation having metals whose valency electron is 1, 2 and 3. Okay, now let's see for the naming of negative ion. Okay, next slide. So in case of naming of anion, so how will we name? So while naming a single element ion, for in case of anion which are non-metal and whose valence electron may be 4, 5 or 6. So in that case what we will write? We will write the name of element from the periodic table and the change the ending with IDE. Then what we will do? We will write the name of element and that element's ending. Okay, at the end what we will do? We will end with IDE. For example, chlorine. Chlorine has valency 1 and it is written as Cl minus. So it is, we will not write like chlorine ion. Instead of that, what we will write? Chloride. IDE is changed. Okay, CHLORIDE. So their extra IDE is added. Okay, so bromide, bromine is bromide, hydrogen is hydride, oxygen is oxide, phosphorus is phosphide, carbon is carbide. So in all that case what we find, simple atom or simple element name at the end it is changed by IDE. So calcium chloride. So when we are saying calcium chloride, so calcium ion plus chloride ion. So chloride means it is indicating chlorine Cl minus. So valency 1 there. So in that case while forming the compound later on we will study. So there we have to understand the naming of an ion is given by replacing or adding IDE at the end of the element. Okay, is it clear? So other elements are also there. We will discuss in a table in next slide. Now next is naming of compound radicals. So there are different types of radical we have to study in our course, and while forming the compound we will study. Okay, we will learn, we will practice. Okay, now for naming compound radicals, so how we will name the compound radical? So there are many rules. So one of the rule for instance is I am giving to you, if there is oxygen in the compound radical. Okay, if there is oxygen in the compound radical, then the radical with the lower number of oxygen atom in that radical, for look their example, sulfite and sulfate. Okay, what is the formula or radical formula there? SO3 minus. So both of them they are SO3 2 minus, that is both of them having valency 2. Okay, having charge 3, charge minus on both of them. In sulfate also 2 2 minus, and in case of sulphide also 2 minus. But there what happening, in oxygen 3 atom is there, okay, in sulphide, and in case of sulphate how many oxygen atom is there? 4. So in that case, where oxygen is involved in the compound radical and where the oxygen number is lower, there we will add suffix ITE. What we will add? ITE. And whereas the compound radical where oxygen is involved and the number of oxygen atom in that, comparatively when we compare to that, if the number is less, similar type of compound, then what will happen? The lower one will carry will be added with ITE, whereas ATE will be for the higher one. Okay, suffix is given for higher number of oxygen atom involved in that will be given as ATE. So if ATE is there or ITE is there, you have to understand that in that compound radical oxygen is involved. Okay, so like that, another example is there. So NO2 minus and NO3 minus, that is nitrite and nitrate. Okay, nitrite and nitrate. So in this case also they will have same valency, but the number of oxygen is differing, there. It is different. Okay, in one there are 2 oxygen atom, in another there is 3 oxygen atom. So name is given us like that. Nitrite ITE is written there and nitrate ATE is written. For lower one ITE, for maximum ATE is given. Okay, so in this way we can give the name of some compound radicals. Sometime bisulfate, sulfate is there. So sometime if hydrogen comes in front of the particular radical, then bisulfate, sulfate formula is SO4 2 minus and bisulfate is there, so their valency may be different. Okay, but if they have sulfate and bisulfate, then HSO4 it may be there, H will come from. So if bisulfate is there, you have to understand that hydrogen is at the beginning, okay, at in front of the element. Okay, so that's naming also is there. We will discuss in next class if possible. Okay, otherwise we study this much for time being for in this class 9. Now let's see the other table. Okay, next slide. So some example of radicals or ions. So look at there. So acid radicals and basic radical. Already I have told what is acid radicals. Electronegative radicals are called acid radical, and which carries positive charge on them, they are called the basic radicals. So there some examples are given along with their valency. Monovalency means monovalent means having one valency, and bivalent means valency 2. Trivalent means having 3, like that. Okay, so look at here, chloride, chlorine, iron, Cl minus. Okay, it is a negative and Id is added there, as I have already told how to name the radical. Okay, about the anion I have told. Fluoride, Fl, that is fluorine, actually element is fluorine, but after losing one after gaining one electron it will carry negative charge on it, then it will be called as fluoride. Similarly bromide, it will gain one electron. Iodide, it will gain one electron, it will carry negative charge on it. Similarly nitrate and nitrite, so already I have explained why AT is given, IT is given. Okay, so nitrate because they are comparative element having similar formula. NO, in both the cases NO is there, nitrogen is also there, oxygen is there, but differ is only the number of atom, and lower one is given with ITE suffix and AT is given for the higher one. Okay, so nitrate and nitrite. Similarly hydroxide, OS minus, bicarbonate. So here I have explained earlier, bicarbonate it is coming, then carbonate is CO3, okay, 2 minus, and here bicarbonate means H is at the before, okay. So HCO3, if bi is coming, that means you have to understand carbonate, bicarbonate. So in front of carbonate H will be there, so that is bicarbonate, SCO3 minus. Similarly sulfate, if you see the sulfate SO4, 2 minus it will be there, but in case of bisulfate H is in front of sulfate ion and it will carry it will have HSO4, okay. Similarly cyanide, Cn minus. Similarly about the basic radical, hydrogen H plus ion, that is H plus, they are all positive radical, means metallic character they will show, and they are mostly they are metals like potassium K plus, silver Ag plus, Q plus Cu plus, Aurus Au plus, ammonium NH4 plus, and generally in basic radical, in compound radical only ammonium is a single basic radical, okay. Compound radical, or we can say compound basic radical is ammonium NH4, otherwise all are simple radicals, simple positive basic radicals, okay. So mercurous Hg plus, cupric Cu2 plus, and mercuric 2 plus, Hg2 plus, they are bivalent. So monovalent and bivalent we have discussed, okay. Next slide. Next slide please. So radicals, example, other example are chloride, fluoride I have given, okay. Next slide please. Okay, we will discuss this later on, okay, about other element also like carbonate, sulfate, sulfite, oxide, nitrite, phosphate, phosphite, okay. All these element you can see there, okay. What is their valency? Bivalent means having 2 valency, and trivalent means having 3 valency, and At is written there, okay, like phosphate, phosphite, look there, phosphate, At is there, It is there, that means at the end what is there? Oxygen is there, and out of that which one has lower one? It is given, and which has number of oxygen more atom, that is At is given. So same that is there, okay. So similarly other radicals are there. So having different valency, it is shown there, you can understand by looking at this table, okay. And this is very much important, and you have to understand, as well as sometimes you have to memorize the radicals formula along with their valency, because in next class we may go we have to start with the ionic bond and ionic compound. About that we have to discuss. So you have to remember all the radicals along with their valency, so that while forming the molecular formula or a compound we will find very easy, okay. It's time over now. For tomorrow we have to study other thing, so be careful, stay at home, stay safe. For today this much, thank you.